Guys, this is Karan. I live in Saudi Arabia, studying 9th grade in Yambo International School. Today, I have a topic for you, which you guys might have heard, but you don't know exactly what it is. So, it's called friction forces. Okay. So, what we are going to learn in this section is behind me, friction, of course, coefficient of friction, symbol mu. Okay, and this symbol, if you can see, is U-turn symbol. Okay, what's the U-turn symbol actually meant in physics? Okay, now we are going to learn static, kinetic, and then equation. And of course, when we have equation, we have lots and lots of problems. Okay, so let's start off with friction forces. So friction forces arises when two surfaces try to slide past each other. Okay, even the smoothest of the surfaces have microscopic grooves in them. If you have ever seen a highway surface with grooves in it, then you have a pretty clear idea of what I'm talking. Okay, when two surfaces are slid across each other, the little bumps and valleys catch together and stick briefly. This causes friction. Okay, that is it. That causes friction. Now, I'm not just gonna tell you and make you guys remember what is friction. I'm even going to draw an example of how the friction looks like in microscopic groove. It's for those people who haven't seen it. Okay, now it basically looks like this. When you have a road, like this, okay, you have a road like this, right? Pretty clear idea. Okay, now what happens is, let's take this part over here. Okay, let's zoom it. When you zoom it, and this is the zoom version, okay, so what happens is, when you see this tiny thing, and okay, looks like that. So this is basically what causes the friction in the world, and that is the reason when you drive a car or your bike or your dirt bike, it doesn't go on forever. If it did, we wouldn't have to use a petrol. Okay, well, just a little bit of petrol and then you can go on forever and you can never stop. That's pointless. So okay, so if you have friction, that is why you make the car or your bike stop. Okay, now what is coefficient of friction? Well, the amount of thickness between two material is called coefficient of friction. Now later on, I'm going to be telling you that I have a chart, okay, like I did in thermal physics. Okay, I'm going to have a chart which gives the approximate values of coefficient of friction. Okay, now the URL is going to be in the description. Okay, and it's the values of coefficient of friction. Okay, now let's talk about symbol mu. Now the symbol is like this, and again it's a U-turn kind of symbol, U-turn. Okay, now what it means is, it's a Greek letter which means mu. Okay, now there's two kind of mu's. One is static mu and one is kinetic mu. Now this kind of symbols is in the chart which I have given you in the description. Now here's what I'm going to tell you what's the difference between US and UK, which is static mu and kinetic mu. Well, static, if you see the word static, it means it's not moving, it's at a rest. Okay, so static basically means that object which is not in motion. Object which is not in motion. Okay, now you might have guessed it, UK is opposite to US, which is static. Okay, now it means that object which is in motion. When an object is in motion, you use this kinetic, and when an object is not in motion, you use static friction. Okay, so don't get confused when I tell you to pick the word US or UK. Okay, now let's talk about the equation. Now it turns out that friction depends on the material and support provided. So friction depends on the materials and the support it provides. Okay, so keeping that in mind and putting that in the words in form of equation, it would kind of look like this. And this is friction is equal to mu times. Okay, now what is Fs? Okay, now here I'm going to define everything for you guys. Now F over here, okay, let me erase this. F over here stands for friction is equal to, this is mu times, what is Fs? Well, Fs is support force. F stands for force, as we all know, and S stands for support force. So you put friction is equal to the coefficient of friction times support force. Okay, and the coefficient of friction is the mu. Okay, now keeping this thing in mind, let's go ahead and solve an example. Okay, it says the box rests on the floor. The floor provides us a support force of 127 newtons. The material of the box and the floor have combined coefficient of static friction of 0.42. How much friction force can be produced? Now look back to the question. It says static friction. Okay, it's not moving, we know that. Okay, and its static friction is 0.42. Okay, and the support force which is given is 127 newtons. Knowing this formula, let's go ahead and solve it. So we know that friction is equal to coefficient times coefficient of friction times support force. Okay, now the friction is equal to 0.42 as given, and the support force, which is 127 newtons. Now if you multiply these two numbers, you should be getting friction is equal to 53.3 newtons. So that is how much friction is being provided. Okay, that's how much friction can be produced. Okay, now I have one more question for you guys. Okay, you are skiing in preparation for a competition. Okay, you're skiing for, like, let's say X Games, like, you know, those big events, and you notice that mountainside provides you with 346 newton of support force. Okay, the snow under your wooden skis, okay, the skids are wooden, is fairly wet. Okay, the snow is fairly wet. How much friction force acts on your skis as you move down the mountain? So is it static or kinetic? Well, it says as you move down to the bottom of the mountain. Okay, down the mountain. So you're moving, and then when you're moving, it's coefficient of kinetic friction. So kinetic friction is what we are using. Okay, and it says it provides you with 346 newton of support force, but we don't know how much coefficient. Well, you need to look in the chart which is in description, and the description leads to my Twitter account, and if you go to that, please, if you check the picture out, please go ahead and click follow to my account. Okay, Now let's get back to the question. Now we know that friction is equal to coefficient of kinetic energy is what we are going to use here times support force. We're not given this, so we need to find Wootton's case on fairly wet surface, okay, and that gives us to be 0.10. Now the support force is 346 newtons. Okay, now if you do this, you should be getting 34.6 newtons. So the friction on the snow which you have for playing the X Games or the big event of any concert or competition, okay, is friction is equal to 34.6 Newton. So friction is 34.6 Newton, which is acting on you, okay. Now if you like my video, please go ahead and subscribe, like my video and message me your name so I can put your name into one of my examples. Thank you.